Sure. I've got a three-phase inverter here. It's producing a three-phase output voltage, and it's got a DC bus in terms of a battery. The voltage is quite low. This transformer here, it's only 15 volts phase to phase. I'd like to connect this inverter up to this and not have things go wrong. So I've got control of voltage and I've control of phase. So what do you think? What do you think we should do?
Well, we want to turn it on for starters and then run it and see that the current is in phase with the voltage.
But before we connect it up, I'm a bit worried that if the phases aren't right, it's going to draw a lot of current. So can we do any checks?
Check the resistors that we've got for protection.
Yeah, so I think they're okay. I just checked them before the video. What about the phasing? You reckon we can look on the Pro and see whether the phasing is correct?
Yes.
Okay. So on the oscilloscope, we've got the purple one here is the actual voltage measured from the transformer. And this is a representation of the inverter voltage. Even though it's not being produced at the moment, that's where it will be produced when we turn it on the computer. Another little anomaly is that we have previously worked out that that size of the oscilloscope is an equal voltage to the voltage at that other point. So we just have to know that that happens to be exactly the same. So that's our phase at the moment. Can we try another phase?
Yep.
Okay, so that's another phase from the inverter. Let's see if it corresponds to the phase on the mains. Okay, that's pretty good.
Try third.
Yep. Okay, that's another inverter phase, and this is, yeah, that's looking pretty
Yep.
good. Okay, so who's got the phase?
I've got phase.
Do you want to just make the phase wobble to and fro and just show that we definitely can get it to go either way and then back to where it was again? Yeah, that looks pretty good, doesn't it? Okay, so that looks pretty well lined up. And just based on our earlier things, it looks like that'd be too low, that'd be too high, and that might be just right. So I'm going to risk it and get rid of the resistors, and if you make the inverter run, let's see what happens. Ah, okay. Bit noisy from the 17.5 kilohertz square waves that's coming out. Not much current flowing. Who's got the voltage?
You've got the voltage.
Well, I'm going to reduce the voltage because if my inverter has less voltage,
It's going to
it's
take
going to
current.
extract power, isn't it? That's it. Ah, there's current flowing. Oh,
Yep. But we're out of phase.
the current's not in phase.
Mm-hmm.
So we're back in. Oh, hold on. Oh, yes. Yeah, so I need to look at R phase because that's R phase current. I'm sorry. There we go.
So let me just
Yes,
change this
phase.
to.
Ah, that's better. Okay.
Yeah.
Can we correct that current phase?
Maybe at the voltage.
Tends to be
Touchy,
a little.
touchy.
Okay.
About that.
All right, and if I wanted a bit more current, I could pull the voltage back a little bit.
Yep. And
And
it'll
if
be
I wanted a
very
bit less
close.
current, I could pull it back the other way
Mm-hmm. Further.
and make current go in the other direction, as it turns out. Okay. Well, that looks like that is taking a roughly sinusoidal current in phase with the main, so that's the most efficient way
Yep.
for power flow, isn't it? Just try another phase and we'll shift the current
Shift the
phase
current
as
column.
well.
Okay, I'll go
Which
to S.
S phase, which I think is that one voltage wise.
Yep.
Yep.
Yeah, white, that's one.
And S phase, well, it's still a trial and error there. There it is. So that's pretty good.
Yeah, very close.
And the last one,
T.
go to this phase here. And check this one too.
Yeah, so we're going the wrong direction.
Oh yes, because physically that's in the
That's-
other
yeah.
direction. Okay.
Okay.
Alright, so we've got 3 single phases, currents in phase. Looks like that's working okay.
Yep.